Avoiding individual runs from each piece of equipment directly to the grounding stud is generally recommended. The purpose of the ground stud is to create a central grounding point. This ensures that all equipment within the rack is properly bonded to the overall grounding system. Individual runs can introduce the potential for ground loops, which can actually increase the risk of electrical hazards. Implementing copper bus bars is often an effective approach for bonding individual pieces of equipment within a rack. These bus bars offer a low resistance path to ground, aiding in the distribution of the ground connection across multiple devices. It's generally recommended to use insulated posts when mounting the bus bars. Also use insulated ground wire to connect the equipment to the bus bars. The presence of a main technical ground strap running to the technical panel isolated ground bus bar is essential. This provides a solid, direct path to ground for all the technical equipment. This setup is helpful in minimizing noise and interference. Furthermore, tying the grounding studs of each rack into this main grounding strap is crucial for proper grounding and bonding of the entire system. Implementing isolated ground circuits and using insulated ground wire within the conduit alongside the main lines is generally a good practice. Isolated ground power strips can then be utilized to provide isolated ground connections for multiple pieces of equipment. However, avoid connecting power strips from multiple racks together, as this can potentially create ground loops and possibly overload the circuit. While it's not necessarily a strict requirement to tie all equipment to a single phase, it's often considered a best practice, particularly for smaller to medium-sized setups. Distributing the load across multiple phases is beneficial for the electrical system. This can contribute to a reduction in noise and interference. In larger facilities, connecting all equipment to a single phase may not be practical, and further considerations may be necessary to ensure proper power distribution and grounding. Mounting racks on 4-inch by 4-inch wood beams can be acceptable for many installations. Ensure the wood beams are treated for fire resistance. Adequate ventilation is also needed to prevent overheating of cables and equipment. Consider using grounding clamps to connect equipment to the grounding stud or bus bar. This will provide a secure and reliable connection. Use insulated ground wire throughout the system. This helps prevent accidental shorts and ensures proper grounding. Regularly inspect and maintain the entire grounding and bonding system. This will ensure its integrity and effectiveness over time. When designing and implementing a grounding and bonding system for an audio-video facility, there are several important factors to consider. This is to minimize noise, ensure safety, and maintain the integrity of the electrical system. Let's delve deeper into some of these key aspects. Firstly, the ground stud serves as a central point for grounding all equipment within a rack. It's important to ensure a solid connection between each piece of equipment and the ground stud. This is achieved through appropriate grounding wires and connectors. The ground stud is then connected to the overall grounding system, providing a path for fault currents to flow safely back to the source. Secondly, copper bus bars are an effective way to bond individual pieces of equipment together. They provide a low impedance path for current to flow, which is essential for minimizing noise and ensuring proper grounding. The bus bar should be mounted securely within the rack using insulated posts to prevent shorts and maintain isolation. Each piece of equipment is then connected to the bus bar using insulated ground wires. Thirdly, the main technical ground strap is a critical component of the grounding system. It provides a direct path to ground for all technical equipment. This strap should be sized appropriately to handle the expected fault currents. It should be run in a dedicated conduit to protect it from damage. The grounding studs of each rack are then connected to the main ground strap. This ensures that all racks are properly grounded and bonded together. Fourthly, isolated ground circuits are often used in audio-video facilities to minimize noise and interference. These circuits provide a separate ground path for sensitive equipment, preventing noise from other equipment from contaminating the audio or video signals. The isolated ground wires should be run in the same conduit as the main power lines. They should be connected to an isolated ground bus bar in the electrical panel. Fifthly, isolated ground power strips can be used to provide isolated ground connections for multiple pieces of equipment. However, it is important to avoid connecting power strips from multiple racks together, as this can create ground loops and increase noise. Each power strip should be connected to its own isolated ground circuit. Sixthly, equipment phasing refers to the practice of connecting all equipment to the same phase of the electrical system. This can help to minimize noise and interference. However, it is not always practical to connect all equipment to the same phase, especially in larger facilities. In these cases, it is important to balance the load across multiple phases to prevent voltage imbalances. Seventhly, mounting racks on wood beams can be an acceptable practice. Ensure that the beams are properly treated for fire resistance. Adequate ventilation is provided to prevent overheating. However, it is important to ensure that the racks are properly grounded to the main grounding system. This can be achieved by connecting the racks to a grounding electrode conductor or to the building steel. Additional recommendations include, firstly, using grounding clamps to connect equipment to the grounding stud or bus bar. This will provide a secure and reliable connection. Secondly, use insulated ground wire throughout the system. This will prevent accidental shorts and ensure proper grounding. Thirdly, regularly inspect and maintain the grounding and bonding system to ensure its integrity and effectiveness. Additional information includes the fact that grounding and bonding are essential for the safety and performance of any electrical system. In audio-video facilities, proper grounding and bonding is especially important to minimize noise, prevent equipment damage, and ensure a safe environment for users and technicians. When designing a grounding and bonding system, it is important to follow the applicable codes and standards such as the National Electrical Code, or NEC, and the recommendations of industry experts. The grounding system provides a path for fault currents to flow safely back to the source. This protects equipment and personnel from electrical shock. The bonding system connects all metal parts of the electrical system together. This creates a low impedance path for current to flow. This minimizes voltage differences and reduces the risk of electrical shock. There are several different types of grounding and bonding systems that can be used in audio-video facilities. The choice of system will depend on the specific requirements of the facility. Some common types of systems include separately derived systems, SDS, which are used to provide a dedicated power source for sensitive equipment. Isolated ground systems, IGS, which are used to minimize noise and interference. And equipment grounding systems, EGS, which are used to protect equipment from electrical shock. When designing a grounding and bonding system, it is important to consider the following factors. Firstly, the size and complexity of the facility. Secondly, the type and sensitivity of the equipment. Thirdly, the local codes and standards. Fourthly, the budget. In addition to the basic grounding and bonding system, there are several other measures that can be taken to minimize noise and interference in audio-video facilities. These measures include using shielded cables, installing surge protection devices, and using power conditioners. Grounding and bonding is a complex topic, and it is important to consult with a qualified electrical engineer or contractor to ensure that the system is properly designed and installed. By following the recommendations in this document, you can help to minimize noise, prevent equipment damage, and ensure a safe environment for users and technicians in your audio-video facility. Here are some specific recommendations for grounding and bonding audio-video equipment. Firstly, use a dedicated grounding electrode conductor (GEC) for the audio-video system. This conductor should be sized according to the National Electrical Code (NEC). Secondly, bond all metal parts of the audio-video equipment together using a bonding jumper. This jumper should be sized according to the NEC. Thirdly, use shielded cables for all audio and video connections. Fourthly, install surge protection devices on all incoming power lines. Fifthly, use power conditioners to filter out noise and interference from the power supply. Sixthly, regularly inspect and maintain the grounding and bonding system. This will ensure that it is functioning properly. Here are some additional tips for minimizing noise and interference in audio-video facilities. Firstly, keep audio and video cables away from power cables. Secondly, use balanced audio connections whenever possible. Thirdly, avoid ground loops. Fourthly, use a star grounding topology. Fifthly, use a common ground point for all equipment. Sixthly, use a Faraday cage to shield sensitive equipment from electromagnetic interference, or EMI. Grounding and bonding is an essential part of any audio-video system. By following these recommendations, you can help to minimize noise, prevent equipment damage, and ensure a safe environment for users and technicians. Consider the specific requirements of your audio-video facility when designing a grounding and bonding system. A properly designed system will ensure the safety and performance of your equipment. Seek guidance from qualified professionals in electrical engineering or contracting for proper system design and installation. Regular inspection and maintenance of the grounding and bonding system are essential for ongoing performance and safety. Ensure that all connections are secure and free from corrosion. Promptly address any issues or concerns to maintain the integrity of the system. By following these recommendations, you can create a safe and reliable audio-video facility that meets your specific needs. Remember, grounding and bonding are critical aspects of electrical safety and should not be overlooked. Properly implemented grounding and bonding practices are essential for minimizing noise, preventing equipment damage, and ensuring a safe environment. When in doubt, consult with qualified professionals for guidance and support. Grounding and bonding, while seemingly technical, are foundational for the reliable operation of any audio-video facility. Taking the time to understand and implement these principles will result in improved performance, reduced downtime, and a safer working environment for everyone involved. Remember that the specific needs of each facility may vary. Tailoring the grounding and bonding system to those unique requirements is essential for optimal results. Consider the types of equipment being used, the size of the facility, and any specific noise or interference concerns. Addressing these factors will ensure that the grounding and bonding system effectively meets the facility's needs. In conclusion, grounding and bonding are essential for the safety and performance of any audio-video facility. By following the recommendations outlined, you can minimize noise, prevent equipment damage, and ensure a safe environment for users and technicians. Remember to consult with qualified professionals when needed and to regularly inspect and maintain your grounding and bonding system for continued performance and safety.